Okay, I'm going to do a quick tutorial on angles of elevation and depression. And whenever you are dealing with these types of problems, they're all word problems. And so we were going to draw a right triangle, and we're going to correctly identify the sides and the angle that is provided. If they're asking you to find an angle, of course we would put it as an X, and then we would determine what that angle measurement is. And the way that we do that is we use SOHCAHTOA. So let me get my edit tool out. And so at the top here, we're going to use SOHCAHTOA to solve these problems. And we need to know the difference between angle of elevation and depression and how those things are similar. So the first thing we're going to talk about is the angle of elevation. The definition of the angle of elevation is an angle that is formed by an object's horizontal line of sight. So say I got Bob here. And so his horizontal line of sight is this dotted line. And say he looks up at an object above. Maybe he's looking at a bird or an airplane or something. So this angle that's formed by the horizontal line of sight and the line of sight to an object above, because its angle of elevation is going to be elevated, think about it that way, it's going to be looking up. So this is a right triangle, and this angle is called the angle of elevation. Give Bob a face. So anytime you have an object and they're looking up from a horizontal line of sight, that is the angle of elevation. The angle of depression is if you have an object that's looking down. So say I have Bob and his horizontal line of sight, but now he's looking down at an object. So here's my right triangle, and here is my angle of depression because he is looking down at an object. Say he's standing on a cliff, or he's in a boat, I think is the other picture that I have drawn, and he's looking down at an object, whatever that object is. All right, so there's a very important note that you need to know, and that is most times we draw our triangle probably the same way each and every time. And so if they're talking about the angle of elevation, very easy to spot that. It's going to be with the horizontal line and the hypotenuse. So this dark angle that I'm coloring in, that is the angle of elevation. And then the angle of depression would be this dotted line and the hypotenuse, which I'll darken. This is the angle of depression. And so if you recall anything about parallel lines and the Z, those are alternate interior angles. So angle of elevation is congruent to the angle of depression. And so when we're working with word problems and we read the word problem, if they say angle of elevation or the angle of depression, we generally draw our triangle probably the same way every single time. It's going to always be the angle that contains the horizontal line of my triangle and the hypotenuse. So most times we draw triangles like this for every single word problem. You may draw them exactly the same each and every time. And when you do, I don't care if they say angle of depression or the angle of elevation, you're going to label this bottom right-hand corner, because that is going to be congruent to the angle of depression. And some students will end up putting that angle of depression, oops, let me use a pen here, up here at the top, and that is incorrect. This is wrong. Don't put the angle at the top. Put the angle always at the bottom right-hand corner, if that's how you're drawing your triangle. In our examples today, that's how I'm going to draw my triangles. They're all going to look the same. And so therefore the horizontal line and the hypotenuse, I don't care if it says depression or elevation, that's where I'm going to put my measurement. And the reason why we can do that is because the angle of depression and elevation are congruent to each other because of alternate interior angles. All right, with that being said, let's take a look at some examples. The first example, we have Erin, and she's meeting some friends at the Princess Castle in Disney World. She sights the top of the castle at an angle of elevation of 38 degrees. From the park's brochure, she knows the castle is 190 feet tall. If Erin is 5.5 feet tall, about how far is she from the castle to the nearest foot? Again, I know this is a right triangle because of the keyword angle of elevation. And so I draw myself a right triangle. And I'm going to label the pieces that I know. It's told me I have an angle of elevation. My castle is 190 feet tall. Aaron is 5.5 feet tall, so that's going to come into some play here. And we want to know how far is she from the castle. So here is my castle. I'm going to draw a beautiful castle. And sometimes drawing a picture helps figure out where your image goes. Okay, so I got my beautiful castle. Don't judge. I've never been an artist, but today I am. So here's my castle. And I know it's 190 feet tall. Erin, she is ready to meet some friends, and she is 5.5 feet tall. And so now I can label the parts of my triangle. Okay, here's my right triangle. And I am looking for how far she is from the triangle. So I can call that X. I know that the angle of elevation is 38 degrees. Again, that always goes with the horizontal line and the hypotenuse of my triangle. But here I have some extra information. I know that she is 5.5 feet tall and my castle is 190 feet tall. Anytime they give you the height of the object, you need to subtract that, or excuse me, if they give you the height of the person, you need to subtract that from the height of the object. So my object here is the castle, and I have Erin, and she's given 5.5 feet tall. So we need to subtract that from the 190. So 190 minus 5.5 feet is 184.5. So that's the height of my triangle. So I can use this information now to find X, and I will use SOHCAHTOA. So we studied SOHCAHTOA yesterday, and so we're going to circle the angle that's provided, and we're going to identify the two sides that are given. So X is next to my angle, so it's adjacent. 184.5 is across from the angle, so that's my opposite. So I have an O and an A, and that is tangent. You always put your angle after your trig, equals the O over the A, because it is TOA. Think SOHCAHTOA, we're using TOA. So I'm going to put the O first, which is 184.5, over the X. So I told you guys the other day, if X is on the bottom, you would divide, and that's because you're going to flip these two pieces around. So 84.5 switches with that X, gives me tangent 38 on the bottom. All I did was flip those two pieces together, and we can do that because that's how math works sometimes. All right, so in my handy dandy calculator, make sure you're in degree mode. And so if you're using Desmos, you would, let's see if I can slide my graph out of the way. We are going to do 184.5 divided by tangent, which is there, and my angle was 38 degrees. And so if you look, my thing is not correct because I'm not in degree mode. So I'm going to flip that back to degree mode using my little wrench here in the top corner. So I get 236.149 yada yada. And so I think it says round to the nearest foot. So 236 feet. So this answer is 236 feet because it says round to the nearest foot. All right, so again, if they give you the height of the person, subtract it from the height of the object. Draw yourself a right triangle, label your pieces, and then decide on which SOHCAHTOA part you would use. Write your equation, X is on top, multiply, X is on the bottom, divide. All right, so I'm going to look at some example problems on the back side of that worksheet that you have. So I'll keep that. I'm going to flip my paper over. And so we're going to look at this, and of course there's that note again about the depression and the elevation being congruent because of alternate interior angles. And that's that Z. So because I have alternate interior angles, depression and elevation are congruent to each other, so we can use that information. Every time we draw a triangle, we're always going to put my angle down here in this bottom right-hand corner. All right, so number one, it says you stand 40 feet from a tree, and the angle of elevation from you to the top of the tree is 47 degrees. How tall is the tree? So I know I'm going to need a right triangle. going to label my angle of elevation, the bottom right-hand corner of my triangle, always. And I know that I'm 40 feet from the tree. So you can put you here and your tree over here. So you're 40 feet from the tree. And the question is, how tall is the tree? So we put X with the height of the tree, the height of the triangle. Again, we're going to circle the angle, identify the sides. I have adjacent and I have opposite, and that is the O and the A, so that is TOA. TOA tells me I'm going to use tangent of the angle equals O over A, so that's X over 40. And so because X is on top, I'm going to multiply. So in my calculator, I'm going to do 40 times tangent 47. And that's because I can just cross multiply these two together. I'm not going to switch them. I only switch them if X is on the bottom. Here I'm going to multiply. So in my calculator, I'm going to put 40 tangent, oops, I don't want to use that calculator. 40 times tangent of, what was that angle again? I already forgot. Old age problems. 47. All right, and my answer is 42.9. That rounds to 42.9. So I can say that my answer, because it doesn't tell me what to round to, so we can round to the nearest whole number, I think is what I did in class. So 42.9 is 43. So this is 43 feet tall, approximately. All right, number 2, I have, again, a right triangle. Tells me the angle of elevation to a building in the distance is 22, so that goes in that bottom right-hand corner always. You know the building is 450 feet tall, so that's the height of my triangle. You want to estimate the distance to the base of the building, so the base would be the base of that triangle. Circle the angle given, identify your sides. Again, this is tangent because I have opposite and hypotenuse. So tangent of 22 equals opposite over adjacent. X is on the bottom, so this is where we're going to switch these two around and get 450 over tangent 22. So in my handy dandy calculator, I'm going to put 450 divided by tangent of 22. And I get 1,113.8. But if we're rounding to the nearest whole number, that would be a 1,114. 1,114 feet, because it said estimate, and we're just going to round all these to the nearest whole number. Just make sure you read your instructions. All right, number 3. Right triangle. And it says a plane is flying at an altitude. Altitude is always the height. So the height of my triangle is 10,000. Airport is scheduled to land 50 miles away. So here's above is where my airplane is. So we always measure distance on the ground level. So this base of my triangle is 50 miles. And I need to convert this. Anytime you have mixed units in a word problem, you need to make sure that you convert them to the same units. That's why they gave us the hint that there are 5,280 feet in a mile. So I need to convert this 50 miles into feet. So I'm going to multiply that by 5280. And 50 times 5280 is 264,000. All right, and we are asking to find the angle at which the plane must descend. So of course, if my plane is up here, I'm looking for this angle, but that's on the outside of my triangle. That's because that's the angle of depression, and we know it is the same as the angle inside the triangle because of alternate interior angles. So I'm looking for that angle at the bottom right. Just like I have always been given, angle of depression and elevation is in the same location. All right, so I've got opposite and adjacent. So this is tangent of an angle equals the opposite over the adjacent. So to find the measurement of an angle, that's where we go to our calculator and we do the inverse. So if you're using Desmos, you're going to go to functions and go to the inverse. And this is tangent, so we do the inverse of tangent. And we had 10,000, careful with your zeros. Divide that by the 264,000. And so the angle I get to the nearest degree is 2 degrees. 2 degrees is all that is. So that is number 3, 2 degrees. I'm going to erase some of this to give myself some more room. All right, number 4, and you can always pause this video and see if you can try these to get the same answer that I'm getting. Number 4, you've got, again, a right triangle. The lake measures 600 feet across, so that's the base of my triangle. And the lodge stands on one shore. From your point on the opposite shore, the angle of elevation to the top is 4 degrees. How tall is the lodge? So the x goes on to the height of my triangle. A lot of these are going to be tangent, I think. Circle my angle, opposite over adjacent. So that is tangent of my angle equals opposite over adjacent. Again, x is on top, so we're going to multiply. So in your calculator, you would put 600 times tangent of 4 degrees. So here we go, 600 tangent 4. And it gives me 41.95608, yada, yada, to the nearest whole number, that is 42. So my lodge is approximately 42 feet tall. All right, let's take a look at number 5. Library wishes to build an access ramp for wheelchairs. The main entrance to the library is 8 feet above the sidewalk level. So let me draw my triangle. 8 goes to the height because that is above the sidewalk level. So the base is the sidewalk. If the architect recommends a grade angle of elevation of 6 degrees, so that goes there, how long must the ramp be? So here I'm looking for the ramp. Ramp is whatever you're pushing up and down to the door. So that's the hypotenuse. Because the bottom, remember, is the sidewalk. And this thing is going over the sidewalk. All right, so angle, I've got opposite and hypotenuse this time. So that's OH, which is sine. 6 degrees equals the opposite over the hypotenuse. X is on the bottom, so you'll have to divide. So I'm going to go to my calculator. And because I have to divide, oops, I lost my, there it goes. And so now I forgot what that equation was. So I'm going to say 8 divided by sine. 8 divided by sine of 6 degrees. And the answer is 77 to the nearest whole number. Because remember, if you are what's my iPad doing? Did it just die? I think it got tired. Jeez. Let me find my document again. All right, let's go back to where I was. This thing was being rude. All right. Back to my figure. 6, 8, x sine. All right, like I said just a second ago, remember x is on the bottom, so that's where you want to switch. So we say 8 over sine of 6. So this would be 77 feet. That's a long ramp. All right, number 6. I'm going to put that up here where I have some room. Number 6 says 2 buildings stand 90 feet apart at their closest points. At those points, the angle of depression from the taller building to the shorter building is 12 degrees. Again, I'm going to draw myself a triangle, and I know it says angle of depression, but we know that the angle of depression is the same thing as our angle of elevation. So I'm going to put my 12 degrees down here at the bottom. Well, that looks like 121 or something. All right, 12 degrees down here at the bottom. And I know that they're 90 feet apart. So here's building number 1 and building number 2. So they're 90 feet apart from each other. And we want to know how much taller is the taller building. So we're looking for the height of my triangle. Circle your angle. I have opposite over adjacent. So that is tangent of 12 equals opposite over adjacent. X is on the top, so I'm going to multiply the 90 times tangent of 12. So you'd put that in your calculator. I'm almost afraid to switch calculators, so I'm going to use my handheld one, and I get 19 feet. All right, and that is how you do the angles of elevation and depression. So just let me know if you have any questions. Hopefully that's helpful. And if you need anything, just email me or message me on Remind. And I will see you later. Bye.